Okay, so today we're going to talk about geometric figures. And we started talking about geometric figures in our last class, but we're going to continue and go a little further with it. Our objective: students will be able to work with geometric figures to identify key features of the diagram. So last time we talked about undefined terms. I'm just going to go over it. Undefined terms are words that do not have formal definitions, but there is an agreement about what they mean. So for example, a point is an undefined term. Point is the most basic building block of geometry. It has no size, it only has location. You represent a point with a dot and you name it with a capital letter. So when you're talking about points, yes, when we draw our point on the coordinate grid, we could take out a ruler and we could measure that. But it's just a visual representation. A point doesn't have any length or width or depth or anything. It's just telling you where something is. All right, a line. A line is a straight, continuous arrangement of infinitely many points. It has infinite length, but no thickness. It extends forever in both directions. So you can measure a line this way, but you can't measure it this way. Because again, even though when we draw with our pencil or pen or whatever you're using, we could theoretically measure that. It's just because it's a physical representation. But it does have length. With a line, it has an infinite length because it goes on forever. So you wouldn't get a number for a line. And we can name it with AB with the arrows or BA with the arrows. We could also, if there's a little M here, could name this line M. Somehow I lost my M. And when we name lines with one letter, they're always lowercase italicized. So most of the time you're going to use 2 points, A and B, and it doesn't matter which order you put them in for a line. We talked a little bit about planes. We're going to do more with them today. A plane has length and width, but no thickness. It extends infinitely along its length and width. So a plane is just a big flat surface. It's where points can go and lines can go. They can go through lines and line segments, and those types of figures can actually poke through a plane. We're going to look at that today. But yeah, it's just a big flat surface. So it would be like standing in a room. The floor would be your plane, except the room is like goes on forever. There is no entrance or exit. All right, collinear points. Collinear, as you can see, co and line means together on the same line. So, for example, A, B, C, these 3 points are collinear. They're all on the same line. But if we look at X, Y, and Z, these are not collinear. They're non-collinear points because there's no straight line I could possibly draw that would go through all 3 of those points. Because if I connect X and Z, Y is way up there. If I connect X and Y, Z is over here. Hopefully you get the idea. So this, a triangle, or many other geometric shapes, would be great examples of non-collinear points. When you're talking collinear, they should all line up in a row. Coplanar points. So coplanar, that should be an A, on the same plane. So we have our plane here, this blue kind of parallelogram looking thing. That's a plane. And you can see D, E, and F. Those are all coplanar. They're all on that plane. Also, D, E, and G are coplanar. You could draw a plane that would contain all 3 of those points. However, D, E, F, and G, once you get to 4, there's no plane that you could draw that would encompass all 4 of those points. For the most part, most of the time when you have 3 points, you could draw a plane. There are exceptions, but most of the time you can. I'm not going to be that nitpicky, but I'm just pointing it out in case you take a higher level geometry class. All right, define terms. Terms that can be described using known terms like point or line. So a segment, and again, we're going to speak a lot about segments next week. A line segment consists of two endpoints, A and B, and all points on AB that are between points A and B. So AB, and we have our line, little line above it. Notice there's no arrows. Or BA, it does not matter which order you name those in, it's the same line segment. Over here you have line segment PQ, you have, you could also name it QP. You also have PR. Now, if this was a line and had arrows, you could say line PQ and it would be the same as line PR. And that's because the line goes on forever and ever. It's all the same points. But with a segment, PR is different than PQ. PQ is just this piece. PR is this whole thing. That's going to be extremely important next week. I'm pointing it out now. Ray, a line which starts at one point and goes the other direction infinitely. So we have A, B, and C. A is the end point. So you have ray AB or ray AC. Those would be the same figure because again, it goes on forever and ever. So even if you put B, it's going to keep going till it hits C. So it ends up being the same figure, the same representation. However, if you went for ray BC, because you could start here and say BC, it's not the same because it doesn't include this piece over here. All right, an intersection. You should be familiar with this from Algebra 1, but an intersection is when two or more geometric figures intersect if they have one or more points in common. Okay, so we have two lines here. We know they're lines because they have the arrows on both ends, and they will intersect at a point. Here we have a plane, and we have a line, and the line goes through the plane and intersects at this point. Anytime a line is intersecting with something, it's intersecting at a point. Whereas here we have two planes, and this, when we're in person, I actually stack stuff up. I have stuff to physically show you. So hopefully these diagrams aren't too confusing. But when planes collide like that, they actually intersect at a line because they don't intersect at just one spot. And since those planes would go on forever and ever in all those directions, they would keep going with their intersection as well. So I guess a good rule of thumb with intersections is take the kind of lesser figure, like a line is only length, whereas a plane is length and width. So a line is kind of a lesser figure because it just has length, and go down one. So since you just have one dimension, length, you go down to a point. Anytime a line is involved, it's going to intersect at a point. When you have two planes, it's always going to be a line. All right, so we're going to take a look at this. Give two other names for line PQ. So here we have PQ. I will give you a hint. One of them is this little italicized N. So you just have to give me the other one. Okay, looking over the answers that you guys submitted. We said line N, which I gave you, which is good. Remember, for a line, we only use two letters. So someone said PTM, which would actually sort of be this line. And then PS, which is this line down here. We're actually talking about this line that pokes through. It's like an arrow shooting through the plane. QP is good. QP is what I was hoping people would say. And then N, very good. Someone started to write line segment. When you're looking for another name for a line is different than a line segment. So it would be like a student whose name is William. You might be able to call someone named William, I forgot we had a William in this class, so not picking on him. Sometimes Williams are called Bills, sometimes Billy, Will, Willie. You have a lot of options, but it's still the same person. So if we're looking for another name for a line, it still has to be a line. Can't switch over to be a line segment. All right, let's take a look at another one. So plane R, so that's this plane here. And hopefully you guys remember what I said about naming planes. But if not, we'll go over it when you're done. Okay, so for this one, so this big capitalized italicized R can represent the plane, just like a lowercase letter that's italicized, like N, or this M does not refer to a point, it refers to this line. A plane can be named with 3 letters that are on the plane, but you also don't want them to be in a straight line. It's very, very finicky when it comes to naming a plane. So we could have plane TSV, for example, because T, S, and V, they represent length and width. You'd have to spread out in a shape type form. So when you're looking at a plane, trying to name it using points, you want 3 points, and you also want to look for ones that make a triangle. Okay, so a straight line doesn't work. You got to make a triangle. So based on that, we could also name this SPV. Those are different. I mean, you could go on, you could make quite a few names. You could call it plane TPV, plane STV. Could be all kinds of things. There's probably other ones. I'm not really stretching for this. But you notice V is always included because it's the only point we have on this plane that is not in the same line as the other points. So you need that V when naming this plane to show the width aspect, because the S and T and P, they show length, but you need something to show the width so that it goes out. All right, we will go on to the next one. Take a look. Name 3 points that are collinear. Okay, looking over your guys' answers, everybody picked the same 3 points, S, P, and T. Awesome. Yep, they're collinear because they all go in a straight line. This other line that's here that intersects, that only has 2 points, and I'm glad no one tried to do Q, P, T. Nobody included Q, so awesome job, guys. All right, name 4 points that are coplanar. So when we look at this diagram, coplanar means on the same plane or flat surface. So looking over your guys' answers, there were some things that are in there that are not quite right. So somebody picked N, the little lowercase n. So when it's lowercase, one thing that's actually an absolute is it is never a point. Little letters on these types of diagrams always stand for lines. So N can't be a coplanar point because it's not a point. That also applies to M. Here's a really tricky one, R. R names this plane. It is an uppercase italicized letter, and it doesn't have a little circle to represent a point with it. So it is literally just there to name this big plane. It doesn't have a point, it's somebody's name. So you can't pick R either. So that leaves us with some options. So the easiest, most obvious answer for this one that I would expect most people to pick is V, S, P, and T, because they're all on this big flat surface. Theoretically, because these three are collinear, you could pick S, P, T, and Q, because you could draw a plane that would actually go through all four of those points. I think that's less obvious. I would accept that as an answer, but I do not believe the test you are taking on Wednesday has things like that. I'm pretty sure all four questions are very straightforward. You have to be able to see it. So the correct answer, if this was your quiz on tomorrow, it would be these 4 points, V, S, P, and T in some order. Because again, M is not a point, N is not a point, R is not a point. The point should be a letter with a point, like a little circle representing a point. All right, use the diagram in example 1. Give 2 other names for line ST. So how else could you name that line? Okay, so looking over your guys' answers, I see quite a few people that said TS. Awesome. Yeah, if they ever ask you, hey, we have this line ST, you can just flip the letters around. You don't even have to look at a diagram for that. It will always work if it's a line. That does not work for array. Arrays are different. But lines and line segments, yep, you can flip those letters around. It's totally fine. Those would be the same every single time. It's actually called the identity property. We aren't going to talk about that for a few months yet, though. So I don't want to get too into that. I see some other people put PT. That's great. It's on the same line. I see SPT. Remember when you're naming a line, you pick just 2 letters. I don't see any others. You could do TP. You could do PS, SP. You could do line M with a little lowercase m. Do remember, it actually looks like most of you did a great job with this. Remember when you're naming a line, the points are capital letters, just like here. All right, use the diagram in example 1. Name a point that is not coplanar with points Q, S, and T. All right, so we have Q, S, and T. Name a point that would not be on the plane we could draw that would include those 3 points. Okay, so we have this diagram here. If we drew, and it's really hard to visualize this type of stuff for some people, if we drew a plane here, it would actually go through point P, because I see some people said P, which at least you didn't pick a letter that they gave you, so that's good. And it's really hard to visualize that for some people. So I can understand how that could be a little complicated. But V, which some of you picked, which is excellent, V is over here away from all of this. So V is not included in the same plane that these guys are on. So good job to those of you who picked V. Excellent work. All right, new diagram. Yay. So give another name for line segment GH. And we know this is a segment because it doesn't have arrows on the ends of the bar above. So it's just a line segment. Okay, so a lot of you guys got this one. Good job. So it should have been line segment HG. Someone actually literally wrote that out, and it's beautiful and perfect. So very nice work. Actually, 2 of you did that. So very nice job. Remember, this is not a line, it's a line segment, and they are different. But HG is what most of you guys all got. You may not have put it in. And remember, for line segments, you're only going to use 2 letters to name it. So 3 letters is only for planes. For line segments, for rays, and for lines, you always use 2 letters. Unless you're using a line with the lowercase letter, which is why I dislike that, because I feel like it just adds something on that's unnecessary. But I don't make the rules. All right, let's keep looking on. Name all rays with endpoint J. So you've got J right in the middle. That actually is a point. It should be drawn in there, but it's not. So J is a point. Where could you go with rays from J? All right, so naming all rays with endpoint J, right? So if your endpoint is J, the name of your ray is going to start with the letter J. So ray J. And then one person did this absolutely perfectly. He said, okay, I'm going to go JE. And then I'm going to go ray JG. And then I'm going to go ray JF and ray JH. You could start here and you could shoot off in any one of those directions. And any of those would be a ray. You'd start at J and then you go on forever and ever towards E, towards G, towards F, towards H. So hopefully that makes some sense here. And I do realize some of you are probably very confused. Diagrams are kind of hit or miss for a lot of students where they can totally visualize this. In my academic resource class, I talk a lot about learning styles. So if you are a visual spatial type learner, you're good at visualizing, these are probably easy. If visualization and graphics and things like that don't really help you, this might be more challenging. And I'm so sorry for that. All right, so give another name for a line segment, so just the piece, EF. Okay, so we've got some answers. There's only one answer for this one, and it's line segment FE, which, now one person did put JE as an answer. That is not correct. So JE is just the piece of the line that starts from the intersection to E, whereas line segment EF is all the way through past the J and keeps going till it gets to the F. So one of those is smaller than the other, so they can't be the same thing. But you're on the right track. You at least were in the right ballpark. Are HJ and JH the same ray? So remember, HJ would mean you'd start here and go towards J. So I want you to think, what would JH be? Would it be the same thing? So let's talk about this one. So I'm going to draw on this. So ray HJ. So I'm gonna use purple for HJ. So HJ starts at H and then it goes this way forever and ever and ever and ever. Okay, so we got purple for that. Probably should make that a little bigger maybe. Let's try that. Shows up a little better. Okay, so now if I do, let's say green, green's a good color, for HJ. or I'm sorry, JH. We would start at J and we would go towards H. So as you can see, these are not the same figure. They're going in totally different directions. And one of you wrote a beautiful explanation on that, and very good job. Hopefully you know who you are. Most of you guys decided they were the same ray, but hopefully when you look at this, you can see why they're not. One starts here and goes this way, one starts here and goes this way. With rays, the order of the letters matters. You can't flip arrays letters around. That does not work. Line segments, you can flip them around, and lines, you can flip them around, but not rays. All right, sketch a plane and a line that is in the plane. So you guys are going to draw your own plane, and then you're going to put a line in there. All right, and just to clarify, so plane you could draw like this. You know, something like that, a flat surface. And then that, put arrows. And then as many of you did in your things, you put points. You can label those points whatever. A and B work. So some of you did that. So yeah, something along those lines is good. Yep. Okay. Sketch a plane and a line that does not intersect the plane. You know, I'm actually just going to go over this one. Yeah, so if we sketch a plane like this, right, we have our plane. To have a line that doesn't intersect the plane, doesn't touch it, the line would have to be like down here maybe. They could be side by side too. I mean, really the important thing is that this line and this plane have a very special relationship. So what relationship, if anybody knows, do we have to have for two things to never intersect? Anybody remember that special word we have for things that don't intersect?
Parallel lines?
Perfect, yep. Except these aren't lines, these are just parallel figures, but parallel, perfect and beautiful. Awesome. All right, so sketch a plane and a line that intersects the plane at a point. So what does that look like? We saw one like this earlier. What do you have when you have a plane and then a line that just touches it in one place? Because a point represents one spot, a location. What would that look like? So a plane and a line that intersect. Some of you are on the right track. So real quick, here's our plane. Right, and then a line that would, it's going to poke through it. So we could go to there. Now, just to point this out, if you want to show it's behind something like this, you do dashed lines. You might see that so that you know that that means, right? So you'd have this plane and it would be coming up and it would intersect like here, maybe. And that's where it would intersect. That's the point. You can label the point if you want. So hopefully you guys are feeling pretty good about geometric figures. How do you feel about today's lesson?